So let's take a look at an idea of approximately what the value for the dissociation of water is to make protons and hydroxides. First of all, as we write this thing right here, we see that this dissociation occurs in a way that my immediate thought is, why don't I set up a K value for this? So K is going to be equal to the stuff on the right over the stuff on the left. And we have this result. Now, at this point, there should be these bells going off in my head as I go, wait, water, isn't that stuff like a pure liquid? Am I supposed to include this pure liquid up here as an example of something that goes into this equilibrium expression? Or maybe it's not supposed to be there at all. Well, if you remember, it's not supposed to be there at all. It gets absorbed up into this equilibrium constant here. And if you ask why, it's because this is approximately a constant amount. So the question is, how much is the concentration of water in a bucket of water? So let's do the math. I have 1,000 grams of water. That's approximately 1 liter of water. And because I have 1,000 grams, and these things are 18 grams per mole, these water molecules, this is about 55.4 moles of water associated with that 1,000 grams. But it's in a liter of water. So the molarity of water is going to be equal to 55.4 moles divided by 1 liter. Is going to be approximately equal to 55.4 molar. That's the answer to this question. How much is this? It's about 55 molar. And it's constant. As long as the amounts of proton and hydroxide in solution are relatively small, then I would be able to say that that value is going to be 55 molar, and I can just absorb it up into this particular equilibrium constant. If I do absorb it into this equilibrium constant, I create an entirely new equilibrium constant value, and that value is something that we're going to talk about a lot. It's going to be something called the KW. The KW, as we will see in a second, is what happens when I take that water term, which is constant, and I absorb it up into the equilibrium constant expression.